We're going to talk a bit about a notation you may not have seen before called sigma notation. And sigma is a Greek letter. It looks like this. And really what that symbol means in mathematics is add. Add up a bunch of stuff. So it's kind of like a big plus sign in a sense. And usually you'd see it written like this, say. You might see something written like this. And this would be a shortcut way of expressing a bunch of terms added together. So this here is our term, 2k. Those are our terms. This means to start at 1. Start at k equals 1. And go up to 5. So this is our upper limit. And then this just means add them all up. Add them. So if I was to expand this, what I would do is I'd start by putting 1 in for k. So my first term would be 2 times 1, which is 2, plus, because this means add them all up. Then I would continue to put numbers in for k until I reach 5. So my next number I'd put in for k would be 2. 2 times 2 would be 4. Then I would put in 3. 2 times 3 would be 6. And then I put in 4. 2 times 4 is 8. And finally I'd put 5 in. 2 times 5 is 10. And then I could add all this up. 10 plus another 10 plus another 10. So this would add up to 30. But instead of writing 2 plus 4 plus 6 plus 8 plus 10, I could simplify that by writing this here as this expression. So it really it's nothing new. It's just getting comfortable working with this sum notation or sigma notation. So let's do another one here. So this one's only going to have 2 terms because I'm going to start by putting 1 in for k. So that'd be 1 squared plus. And then finally I'm going to put 2 in for k. That would be 2 squared. And then I could work this out. 1 squared is 1. 2 squared is 4. 1 plus 4 would be 5. We don't have to always start at 1. We might have a question that starts at 5 and let's say goes to 7. And let's make a term up here. Let's say it was, well, let's say it was this. Say this was our expression. Well, we'd start by putting 5 in for x. So that would be e to the power of 10. Plus, then we put 6 in for x. Oops, sorry. I got different variables here. Usually we use k when we're working with sigma notation. So I should have, if I started with k equals 5 here, I should have had k here. My variables are the same. So let's start again. We put 5 in for k. 2 times 5 is 10, so I have e to the 10. Then I'd put 6 in for k. That's e to the 12. And finally I'd put 7 in for k, and that would be e to the 14. I can't really add these up. So I would simply have to leave it like that. So this would be a situation where instead of having to write everything like this, it might be simpler to express it like this. And we can have some expressions like this, and we could actually try and write this thing in sigma notation. And I believe what we would need to have is 2k minus 1 here for our terms. And I have 1, 2, 3, 4, 5, 6 terms. So from 1 to 6, let's just check that this would work. Putting in 1, 2 times 1 is 2, 2 minus 1 is 1. Put in 2, 2 times 2 is 4, 4 minus 1 is 3. That's right, and we're adding all these terms up, and there are a total of 6 of them. 1, 2, 3, 4, 5, 6. So this would be a shortcut way of expressing the sum of all of these terms. So that's all sigma notation is, just a way of representing a bunch of terms added together, where this would be the general term. This means add up all these general terms starting at 5 and going up to 7.